today we are picking up, we're going to wrap up this section. Looking at, we talked about all the parabola stuff. So circles are also included in this. Circles are kind of a thing that you don't get to cover a lot. Was that my door? Come in. So they do show up though on the ACT a lot of times, so I wanted to go ahead and include them. It's kind of a topic that just gets skipped in most things. So I just want to give you the basics. A circle is a set of all points from a fixed point HK. Okay, the definition, the center is that point HK. The radius is R, how far away from that center you are. So the equation of a circle in center radius form looks like x minus h squared plus y minus k squared equals r squared. So in a circle, we see both an x squared and a y squared. The amount you are subtracting off, that's your HK, that is giving you where the center is located. And then we have our radius. So first thing, I just want to practice writing the equation and drawing a graph of these. So if I want the center radius form of the circle, so the equation I just gave you is x minus h squared plus y minus k squared equals r squared. In this, the x value of the center is your h, the y value of the center is the k, and your radius is your r. So we plug in. So x minus h, which is 4 squared, plus y minus negative, so plus 3 squared, equals r squared. So 5 squared would be 25. So that's what the equation looks like. When we graph these, what we're going to do is start at our center. So that's at 4, negative 3, and I'm going to put a dot. The circle is everything that is 5 units away from that point. So we'll go 5 in every direction. So if I'm measuring my radius, it would be 5 above. That would be a point on my circle. 5 below would be a point on my circle. 5 to the right of my center. And 5 to the left. Okay, so if I were looking on a test or quiz, I would be checking, do you have your center in the correct spot? Do you have those points in the correct spot? And then do your best to make a circle. My graph is not perfectly square, so mine is looking more like a football in a circle because I did not get my scale perfect. But hopefully yours is a little more square than mine. I'm going to be looking at are your points in the correct spot when I do those. Does anyone have a perfect circle on their paper? Anybody really good at drawing a circle? We're all on the same boat then. Okay, B. So if my center is 0, 0, so that's my H, that's my K, the radius is my R. So my equation is x minus h squared plus y minus k squared equals r squared. What is x minus 0? So it's just x squared plus, what's y minus 0? So y squared equals 3 squared, which is 9. So x squared plus y squared equals 9. Graph. So this time my center is at 0, 0, so we're starting there. Radius is 3, so we go 3 in every direction. 3 above, 3 to the right, 3 below, and 3 to the left. And connect your dots. It's a little bit better than my first one. Any questions about writing the equation or graphing a circle? Okay. From here, just like we saw with our quadratics, sometimes our quadratics are written in vertex form, which is kind of like this, where it was something minus, or x minus something squared. Sometimes it was written in standard form, when it's all multiplied out. So if I give you something in standard form, we need to be able to rewrite this so that we can identify the center and the radius. All right, so this is probably the new piece here, or the biggest piece here. If I want to rewrite this, so our equation we want is to get it into that x minus h squared plus y minus k squared equals r squared. So first I need a parenthesis with my x's. So I'm going to make a parenthesis. I'm going to put my x squared and my 2x in it. And I'm going to leave a little space, and I'll explain why in a second. Second parenthesis, I want to put my y terms. So I'm going to say my y squared, my 6y, and I'm going to leave a little space. This should be equal to r squared. R is my constant. So I'm just going to add this 15 over, so it equals 15. So far, made a parenthesis with x, parenthesis with y, move my constant to the other side. What we need to do is to be able to factor this. So I get something squared, right? I need my x's, I need to factor my y's, and it needs to equal my number. So what we're going to do is complete the square for each variable. We talked about completing the square at the beginning, and I know you did it last year. Remember, in completing the square, we're trying to build a perfect square. So to do that, we take our middle term, which is 2. If you want to make a square, you need 2 identical parentheses. So I'm going to divide that by 2, because half of it would go in each parenthesis. And then I am going to square it, because when you multiply those parentheses, you take it times itself. 2 divided by 2 is, and 1 squared, so I add 1 in here. Now, it's an equation, so if you add something on one side, you have to add it on the other. We have to keep it balanced. Okay. So I added my 1 to my 15 over here. Here's why we did that. If you were to factor this, what numbers multiply to 1 and add to 2? 1 and 1. So this would factor into x plus 1 squared, because it's 2 identical parentheses. So we're making a perfect square so that it'll factor. We're going to do the same thing with the y. So I have a 6y. So first I have to divide that by 2 because I want 2 identical parentheses. So 6 divided by 2, and then we're going to square it. 6 divided by 2 is, and 3 squared. So if I add a 9 here, what else do I have to do? Because it's an equation, we have to keep it balanced. Okay, what 2 numbers multiply to 9 and add to 6? So that factors into x plus 3. Okay, over. Oh, sorry. Yes, y. Thank you. Okay, over here, 15 plus 1 plus 9, 25. So now my center. So the equation is x minus h. If it's a plus 1, what was my h? Negative 1. Because minus and negative would make it plus. Okay, this is y plus 3. The equation is y minus k. So what's my k? Negative 3. My radius. 25 is equal to r squared. So what's my r? 5.
Will your radius always be like a good square?
Not always. So for instance, if this had been equal to 8, you would have to do the square root and break it up, and you'd say 2 radical 2. So it's okay to have a square root for your radius. Other questions? Let's try another one. So I need to get this in my center radius form. So first we group our x's together. So that's x squared plus 4x. Then we group our y's together. So y squared minus 8y. And what do I do with this minus 44? So this equals 44. Alright, our whole goal is to get this to be a perfect square so we can factor it. So we have to complete the square. Same process every time. You take the number in front of your variable, divide it by 2 because we need 2 identical parentheses, and square it. So 4 divided by 2 is 2. 2 squared is 4. If you add 4 to one side, add it to the other. For my y's, and that coefficient is negative 8. Divide that by 2 and square it. So negative 8 divided by 2, negative 4. Negative 4 squared. So we add 16 to one side, which means add 16 to the other. Now this should factor. What 2 numbers multiply to 4 and add to 4? So this is x plus 2 squared, because it was 2 identical parentheses. Okay. What 2 numbers multiplied as positive 16 and add to negative 8? Y minus 4 squared equals, if I add those, 64. So my center. The equation is x minus h, so my h is negative 2. Y minus k, so my k is positive 4. The radius, 64 is equal to r squared. So the square root of 64 is 8. Any questions there? Do we need more problems like that? I am going to do one final example. So I know I have 2 left. I'm probably only going to do one of these. I just wanted to show it to you because, again, this is the type of question that shows up on the ACT sometimes. So I just want to give you guys a chance to see that before. Quadratics are really good at modeling vertical motion. If you think about, if you take a basketball and throw it up in the air, what's going to happen? It's going to come back down, right? So it's kind of creating a parabola. So we see them a lot in this case. One common equation, if you've taken physics, you've probably seen it a lot. But here, this is gonna fill in your blanks in that box. The height of an object can be given by this equation. So S of t equals negative 16t squared plus v sub 0 t plus h sub 0. This S is talking about the height. T is our time in seconds. V sub 0, V is velocity at time 0, so the beginning velocity. H sub 0, that's your height at time 0, so your beginning height. So everybody should be filling in that box. Write down your equation and what your variables stand for. Look at a problem solving this. A ball is thrown directly upward from an initial height of 75 feet with an initial velocity of 112 feet per second. Actually, so if I want to write my equation, so if you look at that formula you just wrote, we're writing the height in terms of time t. So it's negative 16 t squared plus, what does v sub 0 stand for? Initial velocity. Our beginning velocity is 112 t. Plus, what's h sub 0? Beginning height, and we started at a height of 75. If you started on the ground, what would your initial height be? 0. Alright. V. After how many seconds does the projectile reach its maximum height? So let's think about this. A negative t squared. What's the graph look like? It's a parabola opening down. If I'm asking you for this maximum, what am I asking you to find? The vertex. How do we find the vertex? I did it yesterday quite a few times. So yesterday it was always x equals, here my variable is t, so t equals the opposite of b, so negative 112 over 2 times negative 16. So work that out. I get 3.5. That is my time, so it takes 3.5 seconds to get to the maximum. If I want to know the actual maximum height, what would I have to do? I'm going to plug in 3.5 for my t. We hit 271, we were in feet. Questions there? I am actually not going to do C and D because these two don't work out nicely. You have to use a graphing calculator, and I forgot to change those problems from last year when graphing calculators were allowed on tests to this year when they're not. So I wouldn't be able to ask you a question like that. In general, though, if I asked when something hit the ground, what would your height be? If you hit the ground, what's your height? 0. So I think one of your homework questions does ask this, but it's a nice one that works out better than this one. So if I ask when it hits the ground, you said equal to 0 and solve. This one just does not have nice solutions. I was going to show you on the graphing calculator, but we know that part has been changed from the curriculum. So the homework one does work out nicely though. Alright, any questions?